Here we go. So 15A, here's the difference between a discrete and continuity. See, continuous random variable is one that can take any value in an interval. Those things are not countable, but measured. What are some examples? Time, distance, weight, height. Everyone can be slightly different, infinitely different, just based on the amount, right? And because of that, that leads to a problem. One of the problems is you can't find the probability of a singular random variable x in a continuum. So here's an example if that doesn't make sense what I just said there. Imagine if I gave you a string. I told you from here to here is 10 centimeters, right? And I said, what's the probability of me cutting exactly here? Well, yeah, technically, yeah. But it's hard to work that out, right? Whereas if I gave you discrete, if I told you 1, 2, 3, 4, and I said, what's the probability of me cutting exactly there? That's doable. That's out of 4, you've got 1 in 4 chance. So that's discrete. But continuum, because a string, that could be anywhere on that line, even though I just said 10 centimeters, but to ask you one specific point, how do you do that? Because we need to know the total probability to begin with. But there are infinitely many numbers in between. That's why anything that's measured, like time, height, weight, all of that has an infinite amount in between. So what do we do instead? How do you solve this problem? Is that a question?
Can I tell you not to cut the rope at all?
You could. Then I won't cut the rope at all. But what's the chance of me not cutting the rope at all?
Yeah. How does it change if I ask you?
I don't know. That's a good question. All right. So in continuous random variable, what they've come up with is this. They said, well, what if I split it up into intervals instead? So if I split it up into intervals, now you can count them. There are 2 intervals. If I asked you now, what's the chances of me cutting in this interval, you can tell me. You can then say, well, there's 2 intervals there. You've got a 50% chance of hitting somewhere here. So that's why interval, when it comes to continuous data, how do we solve it? We solve it by working in intervals rather than the discrete. So the interval looks something like this. So just like previously, you get a distribution. The difference is that instead of it being discrete, which is how we've been counting all this time to get a distribution, because it's continuous, the only way to count them is in intervals. So there is, just like Pat said, it's not possible to work out for one particular value, so say 83, but I can work for an interval, say 82.5 to 83.5. 83 is included in that region. Okay? So with that idea in mind, there comes a caveat then. That means if I'm working in an interval, this area under the function will represent probability. But if area represents probability, then all the theories of probability from chapter 13 should still hold. Meaning that probability, if you add all the areas together, it must sum to 1. So that means whatever the function is, when you integrate it, the sum of the function, the area has to equal to 1. Also, we know that probability can't be negative. So that means the function has to be greater than 0. So it has to be above the x-axis. Okay, so there's two parts to that. And that is literally what you're learning in 15A was just literally what I just gave you is a logical sense. Why we're working intervals? Because it's continuous. But then if it is continuous and the area represents the probability, well then it has to follow probability rules. So this is why there are 2 key things that must be satisfied. And if it is satisfied, it's called, and circle this so you remember because the exams use this word all the time. When they call it a probability density function, they're essentially just telling you this function follows the probability rule, meaning all probabilities are positive and the area will add up to 1. Okay, so here, f of x is greater than 0 for all x values. area under the function must add to 1. So negative infinity to infinity of your x random variable, this time is continuous, must add up to 1. Okay? So, that means once these two are satisfied, if it's a probability density function, 15a, that's the first thing you need to understand. That's it. 15a is, do you understand what a probability density function is? Which is just two conditions. Number 2, that means the probability between the intervals, for a to b, the chances of something occurring has to be an interval, not a particular instance, is equal to finding the area under the curve between those 2 points. These are your 2. And that sets the premise for chapter 15. Chapter 15 requires just those 2. And expected value variance is all the same. Expected value is still x times the probability. If this is the probability, then x times that gives you the expected rule. So that's what 15b, 15c is. Variance is the same thing, but you just need to know the difference between the 2. Okay, so 15a today, you're just testing these 2. The knowledge that the area is the probability, and you're testing, is it a probability density function or not? Here's this example. Example 1. Here's your function. You got a hybrid function or a piecewise function. This one. All right. You got a probability density function. The question is, suppose that the random variable x, so it's continuous, is a probability density function, meaning 2 things. The function should be above the x-axis for all x values, and the area should be 1. Now, if you visualize this, it's 0 when it's greater than or equal to 2, and it's less than 0. So that means less than 0 here, the probability is going to be 0. When it's greater than or equal to 2, it's also 0. So you're only sketching Cx. C must be the gradient. Y-intercept is clearly 0. So I've got a graph that kind of looks like this. And it should stop at 2. Now if I visualize that, this area supposedly should add up to 1. Because everywhere else is 0. That's a 0 probability, 0 probability. And for this area to represent probability, it must add up to 1. So this is area of a triangle. 2 is your length, and your height. To work it out, it's subbing 2 into your function. So if you sub f of 2, you get c times 2, it's 2c. So at this point, when it's 2, it's 2c height. To find the area, half base times height, or you could have done integral. You could have done the integral as well, but I'm just looking at diagrammically, I can say it's just a triangle. So half times base times height, half times 2 times 2c should equal to 1. So you can work out c now. So it says find the value of c that makes a probability density function. Area had to be 1. So this now gives me 4c equals 1. Therefore, c must be a quarter. Oh wait, 2. There we go. Must be half. There we go. That was one way of doing it. The alternative method could have been from 0 to 2 of f or cx dx. The area had to equal to 1. So you could have done it this way too. So integrate cx, sub in 0, 2, solve for it. With 1, that would have gave you the exact same answer to find for c. But sometimes when the graph is like a linear, I like to do it through a triangle. But hopefully you can see there's only 2 conditions. All the area has to add up to 1. The function has to be above the x-axis, which it is. And then now, once you know what c is, So now you know what C is the gradient. You can then find probability of x greater than 1.5. 1.5 somewhere here. So they're just saying find that area there. And that area is literally just integration of 1.5 up until 2. C, which is half. That's it. Whatever this is, you can type that on your CAS, or you can do it by hand. And you get your answer. And I got C as half. That's why I just put half in. Okay. Let's do it on our CAS, just because interest of time, and I'm just going to stop there for today. What is the integration? Here we go, shift plus between 1.5 to 2 of half times x dx. And it's 0.4375. So far, so good. I'm going to stop there, okay? Otherwise, it's going to blow your heads out. 14BC was about expected variance for binomial. Key one was the inverse binomial that I wanted you to learn to find n trials. And then 15A, probability density function. Okay, so if I summarize in that sense, hopefully you have a direction on what to focus on. All right, I'm going to stop the video.